Right, algorithm 2 is Kruskal's algorithm. So the difference between Kruskal and Prim is Kruskal's algorithm deals with edges when we're trying to find a minimum spanning tree. Prim's algorithm is focused on the nodes. So Kruskal's algorithm is very straightforward. We pick out the smallest edge, highlight it, move on to the next smallest edge, highlight it, and repeat those steps, preventing any cycles until all nodes are connected. Now, here's the method. Now, what I'd suggest is reading the method yourself, looking at the time on the video, and referring back to it if you ever get stuck. Okay, so that's it. There is one thing to take note of. It's in point 2. If both vertices or nodes are already in the minimum spanning tree, then don't pick it, just leave it till later. And what that will do is it'll prevent any cycles being followed. And you'll see I'll do this with the example that follows as well. So here we go. We don't want to go into that because that's a video, but I'll put up the link for it so you can refer to it later. I'm going to skip it. And we're looking to construct the minimum spanning tree for this diagram. So like I said, it's an edge-based method. We look at the smallest edge, which is 10. We're going to pick that. And we can see that the two nodes there are connected. Then move on to the next one. Then move on to the next smallest one. And I suppose what you notice here is the next smallest one is 16. It would make sense to highlight that. But the two nodes are already in the minimum spanning tree. And if we highlight this now, it's likely that we'll have a cycle somewhere. So I'm going to leave it. Right, I'm going to bank it. I know the 16 has to be there somewhere, but I'm not going to touch it. Next up is the 18, and again, the two nodes are contained, so I'm not going to touch that either. I'm just going to think it's there. We may have to include it later on. The next one up from that is the 22. So we highlight that. Next one up from that is the 24, but again, the two nodes are contained, so I'm going to ignore that. So that brings me to 25. And if we look, all nodes are included, but the tree isn't fully connected yet. It would be referred to as a disconnected graph, as in all nodes aren't connected. So we need to connect the two, the one that's got the 7 and the 2 with the other line. So I can either go 2 and 3 or I can go 7 and 4. It makes sense to pick the smallest one. So like I said, Kruskal's deals with the edges. We start with the smallest one, we highlight that, we work our way up, and the only thing you need to keep an eye on is if the two nodes are already in the minimum spanning tree, we don't connect them, otherwise we may get a cycle. It's likely we'll get a cycle very quickly. All right, so your turn. Use Kruskal's to calculate the weight of the minimum spanning tree. All right, pause this here, work it out, and here is a solution. Right, the answer is 49. Here's another solution. Answer is 49 for the minimum spanning tree. Here is another solution. Right, so there are many solutions to this one.